All right, welcome back. We are COMP397, that's Web Game Programming in the Winter 2020 semester at Centennial, and we're week 6, part 2 of our broadcast. Now we're talking about preloading assets with PreloadJS. All right, so how do we use PreloadJS? We have some assets. Before, what we would do is each time we went there, we would load the asset from the operating system like this. This is no good. Okay, why? It's extra calls to the operating system. Every time I make a button, every time I load something, can you imagine every time I instantiate something, I have to load it from the operating system? It's going to be increased load times, and also we're instantiating the same object multiple times, the same texture we're using, and by loading it in multiple times. From a memory management perspective, not great. Okay, so what I want to do is preload, and one other reason why we want to preload is because of this problem. Before, we had to wait for the object to load before we checked how big it is, right? Because we don't have a size when we don't have an object. I want to get rid of this problem because this is an ugly piece of code to have inside my GameObject, right? So how does preloading work? Well, let's take a look at PreloadJS. PreloadJS is one of the modules or the another library in the CreateJS suite of libraries. So far, we've been dealing with easel.js. That's the main thing that we've been drawing with. We're using easel to draw things on the canvas. What preload allows us to do is it uses AJAX, which is used to stand for asynchronous JavaScript and XML, but what it does now is almost like I want to be able to load things from the operating system asynchronously. Okay? So there's a structure we can use. It creates something called a queue, and the queue creates this thing called the load queue. The load queue can use a plugin to load things like sound and other things. I can wait for the queue to complete loading in order for me to do something. So I can wait till everything's finished loading and then I can start my program, right? I can do two things. I can load individual files first, individually, or I can do something called loading a manifest, a group of files. I'm going to do this part this way, okay? Let's do it. So this happens all in the game.ts file. So in the game.ts file, so far, what we do is this. On the bottom, we wait for the window to load, and then we load the start function. Okay? Now, we don't want to load the start function. We want to load the preload function. I don't have a preload function now, and you can see that it gives me an error. But if I go to the top, before the start function, I'm going to make another function called preload. So, function preload. It's going to return void. And the way it's going to work is this. I need to create a load queue. But load queue doesn't mean anything for us. Let's think about this as assets, right? So I'm going to say let assets be a type of createjs.loadQueue. That's the structure that we've been given, right? Load queue. And what I want to do with this is I want to say that assets, right, is equal to a new createjs.loadQueue. Load queue. So I instantiate my container. So this is the asset container. That's what it is, okay? I also want to install a plugin for the supports createjs.sound, right? Because I want to support sound. All right, so when I load stuff, this supports sound loading or preloading. If I don't have this, then can't load sounds or preload sounds. Then what I want to do is I want to load a manifest, right? So I want to say assets, hey assets, load a manifest, and the manifest is going to be some kind of array of structures that looks like this. I need an ID with a friendly name. Not that name. A friendly name. For example, let's think about our start button. Maybe we're going to call it start button. That's our friendly name that we're going to call it, okay? A name like an associative name. And then we're going to have some kind of source. And the source is going to be where we're going to get everything from. So in this case, it'd be /assets /images / start button .png, right? Okay. So in effect, what I'm doing is I'm creating an array of objects. An array of objects. The first part of the object is a property called ID. The second part is source. If you look here, that's exactly what he's doing here. So when they made their project, it looks like this: ID source, ID source. Yeah. And for every one I load, I can list them all here. Every one that I want to load, right? I can put it here, and then after I'm finished loading everything, I can say that assets.on complete, right? So I do a little event, then I need to call an event handler, and what am I going to call? Start. So I'm going to wait for my assets to finish loading, and then I'm going to do start. Right? That is, my friends, is a way better way of doing things, right? We preload all of our assets, and then we call start afterwards. However, I have to keep this in mind. When we preload, we start using preload, guess what? You can't double click on your index.html anymore. You can't do it. It won't work for you anymore. You have to use some kind of server, like Light Server or something like that, because it uses Ajax, and Ajax will not allow you to double click. It won't work. You need a server to run Ajax properly. Keep that in mind, because you'll have cross-origin problems with Ajax. Okay, so that's good, but you know what? This is kind of crappy to put here. It would be nice if we had our asset manifest here. So let's make this asset manifest, call it asset manifest, which is just equal to an array, this part, an array of objects, right? That's what it is. And then I can just pass in this asset manifest here. Asset manifest, right? So that makes more sense. Let's just pass this to the next level. There we go. And that's what it would need. So I can load my start button. I can load my other stuff. So what things do I have so far? I have a start button, a next button, a back button, and then I have my ocean. So that's all the things I can load. So here's all of them. Right? And this will be my next button, which is called next button. My back button, which is my back button. And my ocean, I'm going to call this just ocean. Every time I say ocean, then it's going to call the ocean.gif, which I've preloaded. So this gets stored inside of the assets queue. Okay? How do I use this now? Now that I've preloaded, I haven't used it yet. I'm just preloading it. Right now, it's still calling things directly. I got to change my code to use this thing. Okay? So the way to do this is, if I look online, it says, well, I need to use queue.getResults. And then I call the friendly name of the asset I just made, like ocean. Okay, but queue, well, that's here, assets. And if I have to use assets in my plane or my player or my ocean or my cloud, I gotta have access to this thing, and it's not available, right? It's only inside my game.ts. I mean, I could pass assets into every object, but that's really a pain in the ass. So I highly recommend using our global config. So here's my global config. We have this thing called scene. Let's make another thing called assets. This is one way you could do it. Okay, so this is just my assets. It's a reference to my assets. So what I can do is, going back to my game.ts, right? When I'm preloading, and I create my assets load queue, I can just make a reference to it. I can say that, hey, config, my assets, well, that's equal to assets. And now I made a reference to the assets in the global config. Right? Okay. Global. I said it. Oh, global's a dirty word when we're programming, right? We don't want to use globals. And it's like whenever you hear global in a C# programming class or Java, the instructor automatically gets this really weird face like this, like it smells, right? Right? And the reality is, it's not a great practice to use globals. However, there are other options that are kind of like global, and one of the patterns we can use is called the singleton design pattern, which we kind of make a global, but it's a little bit of a class as opposed to something like this. I mean, it doesn't matter how we do it. We have to have somehow access to this assets from somewhere. We can pass it in. We can instantiate an object of type game and call the game itself. That could be a singleton. And when we call the game, everything comes from the game. You can do that kind of thing, absolutely. But I think a global configuration file like this, for now, since it's going to be global anyway, makes perfect sense. And it makes it easy. Hey, on that, if this is how we're going to do this, then maybe there's other things we can put in the global configuration file. Like, what about the screen size? We might need that one day. So maybe public, static. We'll call this screen width, which is a number. And we'll say that, well, for now, it's 640. And maybe later on it won't be. Maybe we'll change it to 800 or something like that, right? And we can also say screen height, which is a number, and that's 480. Right? So we can store those kinds of things that are common that we're going to use over and over again. And so I don't want to hard code these things, right? I don't want to hard code them, because then here, if I change 640 and 480, and if I use screen width and height, then everything changes from here, as opposed to I have to go all over the place and change all those things, right? These are like macros. Think of it that way, okay? So let's go back. So yeah, we have these, yay, and other things we can use. Look, FPS. What if I wanted to try the frame rate to be different? So I can go back into my config, and maybe we can say that the default frame rate is something we want too. Public, static, FPS, which is just a number. We can set that to 60, right? So, 60 frames per second, right? That's our FPS, the default FPS. And then if I did this, then inside my game.ts, instead of putting 60, I literally just can put config.game.fps, whatever that is. That way, I can change it one place and it changes everything else, right? So that's kind of the way we want to go. It's a little bit more, it's less hard coding and gives us more control. Okay? So that's that. So we kind of made it so that we can access our assets through this game assets thing, right? That's what we did. Okay, let's make use of it now. So if I go to objects, let's start with object, and I'm going to go to GameObject, the GameObject superclass here. Here's my GameObject superclass. Notice what I'm doing. By default, I'm loading this thing called placeholder. Oh man, I don't have placeholder. Let's go and do that. So inside of my game.ts, this one, let's load a placeholder button. So up here, let's put it up here. Let's call this placeholder. And again, it's placeholder.png. Placeholder, right? So that's there. Here's my thing. And instead of using this as a string, we won't use a string. Well, you make use of a object, because that's what it is. And the object is going to be like this now. It's going to be config.game.assets.getResult. And we're going to call the result that we're going to use the friendly name, which is placeholder. So why this? Because it's not direct file access anymore. We're accessing the asset database that we created, right? We've already preloaded this. We don't have to load it again. We're just accessing that database again. Okay? So that's what this does. And then if we're doing this, then we don't need to do this. We don't need to do this add event listener because we're already waiting for it to load. So we don't have to wait for it to load again. So we're just going to comment this out for now. We're going to come fix it later. Okay, so here we're going to be able to measure the width and the height because we've preloaded this asset. Okay, that's cool. Let's go back and continue. So that's the first place. GameObject.ts. Game button. Okay, button also does the same thing. Button.png. Uh-oh. Button. And got to go back over here and let's take a look at that button, which is here. We have a button.png too. Standard button. Okay. So some defaults we have, and you can see what those look like. If you go up to assets, images, button, it just says button, right? So if you make a button and you don't give a name and you want to test out where the button should be, you can use the default button that we were making before. So that is under my button.ts. So I don't want to do this, just like before. I want to make this a object. And this is going to be a config.game.assets.getResults, and then it's going to be called button. How am I getting this button? Because that's what we named it. We name it whatever we want to name it. So right now we're naming it button. We can name it Tom, and Tom means button. It's up to you, right? But I recommend making it something that's reasonable. Label, we don't need anything. We're not loading anything from label. Ocean, okay. Not anymore. Don't use it anymore. We just replace this with config.game.assets.getResults ocean. Okay? Let's copy that so we can use it next time. Make sense? Okay, player. When we made our little player, we used the defaults. We didn't do anything there. In scene, we don't have anything there. In vector, we don't have anything in there. How about in our scenes? Did we ever instantiate anything in our scenes? I think we did. In our start scene, we said, oh yeah, we want to load the button, start button. Well, we want to replace this part with our start button. Okay? And we want to do the same thing for our play scene, which is right here. This is the next button. So next button. As well as our end scene, which uses the back button. Okay? Make sense? I'm just replacing everything. It's an only one-time thing. From now on, we're not going to do it this way. We're going to make something, put it inside of our asset database, and then use it afterwards. Okay? Now, we made a lot of changes, and we didn't test anything. Let's see if it works. One thing is to change, another thing is to see if it works. Let's go to here, and let's go back to here, and that's not it. This is it. And you see that, well, it looks okay. Now you're like, wait, how can you tell if it's working? Well, if I go inspect, and if I look to sources, then you can see that indeed I'm loading things up. My sources have changed, right? You can also see, if you can also inspect here everything inside. Like for example, my button.ts. You can see that my button.ts uses exactly that, config.game.assets.getResult button, right? And that's how it's being done. In the console, no errors, right? So we know it's working. Cool. We've loaded, we've done the preloading part. Let's put it up on GitHub now. So close all these down. And we'll just collapse all this stuff for a second. Here, let's collapse everything. And what I want to do is, there's nothing to do here. Notice there's no extra stuff to do. We already have PreloadJS. So this is, if we didn't have PreloadJS, we'd have to load it right here. This is the first time we're actually using it. We're still not using tween and sound. It's been there for the whole time, but we never used it. Okay? So let's put it up on GitHub. Now, notice there's 24 changes because I modified so many files, plus all the other JS and JS map files. These all got modified. So again, I'm going to stage everything. And I'm going to say something like added preloading to game. All right, so then I'm going to click this little checkbox, which is like git commit -m, and then push, which is going to push everything up to GitHub. Now, remember, propagation. So it's working here, but if I refresh, it doesn't work here. And do I know that it's even loaded? Again, the way to check is you press inspect, and you can look at the sources, And you can see that under my scripts, my objects, and if you look at that button TS, yeah, see, look, it's already there. So it's already propagated up online. Okay, it's pretty good, and it works like a charm. Okay, so nice and easy. And notice I'm not measuring anymore with that load function. I'm not doing it anymore. So if we look back in here, in my scripts, objects, GameObjects.ts, right? I don't have to use this structure anymore. I don't have to wait for things to load because I'm already waiting for things to load. So I don't have to do this anymore. Let's just delete this now. That was the old code. Out with the old, in with the new. And now our code looks a little better. Okay. Sorry? To move this way and that? Tab actually. So if I highlight it and if I press, sorry, I understand. If I go Shift Tab, Shift Tab moves it back. If I just go in front of it, not on top of it, and if I just tab, it moves it to the right, right? And if I want to move it up and down, I can use Alt, and then the arrow buttons. See? Okay. So you can move things around. Okay. So questions around this, preloading. Any questions? So why is preloading good? Because we can accommodate for all our loading ahead of time. And in fact, you see it in most video games. Screen loads and it takes time. Loading. Right, that little bar that comes across, that's loading, the little progress bar, right? Here, we don't have a lot to load. But there's going to come a time where you're going to see a little bit of a delay. Before it comes up, it's going to go like this. It's going to be black, and then all of a sudden, right? We're going to fix this. We're going to make a little loader eventually, because right now we don't have a lot of assets. We have only a few assets. But later on, when we add more stuff, it might take longer to load every single time, especially when it comes to sounds. Sounds take a little longer to load than everything else because they're big. Megs, right? Here we have kilobytes, right? Sounds big, right? So it's going to take longer. But it's good because if you try and load a sound, if you don't preload sounds, bad things can happen to good people, right? So that's all I can say. So now if you notice, this is all the stuff that we've preloaded. And it all works online. Everything's great. Okay, so next part. I want to add a little plane. That's what I want to do. And if you notice inside of my assets, I have this under images, I have a plane.png. It looks like this. Okay? I want to take this plane and I want to load it, right? Notice it also has a little shadow and stuff. I want to load it and I want to control it with my mouse for now. Okay? So let's do that. So again, if I go back to my objects, under objects, I'm going to make a new file. I'm going to call this plane.ts. Again, it's going to be module objects, just like before. And this is good repetition for you guys. Next week on your tests, you may have to create some objects. I'm going to ask you to do something, right? So you need to know this process. So number one, make a file. This is the first thing. And when you're studying, if you go through these videos, start trying to follow along. Like actually try and start things from scratch. Build things up slowly for yourself. That's one way of studying. The other way is just to make your assignment number one. Like finish assignment number one, you'll know almost everything you need to know for the test. Okay, so let's take a look here. So the next is I need to export. Remember we talked about this. If you don't export, then what happens is anything you put inside of this module is locked inside of here. Export exposes that class. And it also organizes our classes. We don't have to do this. We're putting it inside of modules so that way we organize each class into different parts so that they're not all colliding. Export class, we're going to call this class plane. It's going to extend our GameObject superclass. There it is. And again, just like we saw before, I'm just going to implement the inherited members, right? And just separate this out so that they are done right. I'm just going to get rid of all this stuff. There we go. Okay, nice and easy. And this is going to be the private methods. I'll just do it differently here. We'll have the same comments though. These will be public methods. And I like to put my curly braces on separate lines as well, because for if I can put my curly braces on different lines, I can always just comment this out. However, if I put my curly brace on the same line, then I'll have an error, right? So I can do that. I can add different methods in here, and I need some private instance members, as well as some public properties. Finally, a constructor. Let's start with that. So the constructor, similar to the ocean, is going to have nothing inside of it. I'm going to also call this new image, right? We don't have it yet, but I'm going to say that, hey, config.game.assets get result of something called plane. I don't have this yet. Okay, that's what this does. Let's add this in. I need a plane. So in my game.ts, I'm going to load a new asset called plane.gif. It's going to be called plane, right? And it's going to be PNG. And that is exactly what I told you it was going to be inside of our assets. Inside of our images, you can see that there is a plane.png that I'm loading. Okay. So going back to plane, I've loaded the plane. Yay. I need a check bounds, and I also need a move function. So again, there's going to be a private underscore move. Now you might think, hey, you know what? I'm always adding move and on top of check bounds. Why don't I just put this as part of my superclass? I could. It's not a bad idea. I mean, I have check bounds, and buttons don't have check bounds. So, I mean, I could put that in. And it might not be a bad thing, because most objects I'm going to do something with. Move, right? If I don't use them, I don't use them. But at least every object that I make has that extra function. I don't have to write that in. Okay, so move and check bounds, start, update, and reset. Remember what I want to do with my move? I already have this kind of detailed out. I did it already in something called player. We played around with this. And if you look, I did something that looks like this. My position is going to be a new vector2 with stage mouse X and stage mouse Y, right? So I just want to copy this text right here, because that's what I want to start with in my player. So that's going to be my update. So in my update, sorry, undo. In my move, I want to do this. And in update, I want to call this dot underscore move, as well as this dot underscore check bounds. Okay, what am I checking now? Well, you're going to see in a second what I need to check. But for just to scaffold this out, I want to check the left boundary for my plane, so it can't go off screen. And I want to check the right boundary. That's what I want to check, those two things. Okay? Make sense? So that's what I'm doing. So I make my plane, I check left boundary, right boundary. I'm going to move. Start needs to be called from my constructor. So I'm going to say that this dot start, which is going to be my initialization stuff that I do here. Any kind of initialization I do in start, right? And then reset I can use to reset back to where I am. Okay, if I wanted to do that. I don't think I'm going to use my reset function now, though. Okay, so yay, I have my plane so far. Okay, question. I mean, yes, this is okay, but am I ready? So step 1 is making this. Step 2, adding it to my index.html. That's step 2, right? So I'm going to go into my ocean, we're underneath my ocean, and just say script source dot slash scripts slash objects slash plane dot JS. There we go. And now that I have it, I can use it inside of my play scene. Okay, my play scene has to change now. So we made our plane, but in my play scene has like these labels and buttons. I don't need my play scene to have a label and button. My play scene is going to have my plane. And then if my plane dies, then I go to the end scene. I don't need a button to make me go to the end scene. So I don't need this stuff anymore. This is my test. This was testing. That's what I use these for. So let's get rid of these things. And the same thing goes with these things. I don't need them anymore. And I don't need these anymore. But I do need my plane. So let's add them in. So I said private underscore plane is of type objects.plane, which I'm going to initialize here. And again, I don't like the duplication. I don't like it, just like you don't like it. I don't like this. Because I'm going to do the exact same thing here. So how do I overcome this? Well, if I did this, I made them optional, then can I do this? Yeah. So what does optional mean? It means I don't know if I'm going to have these. That's what it means, right? And so then I can just instantiate them here. But look what happens when I do that. It says this.ocean.update, possibly undefined. So it doesn't allow, the way I've set up my my tsconfig.json file is I say strict null checks, right? Strict null checks. It says enable strict null checks, requires TypeScript version 2 or later. Strict function types, string property initialization, which is this. And if I say that this is false, as an example, instead of true, oops. And if I go back to here, then what happens is I may not get this thing happening. Strict property initialization. If I close this file off, as an example, this my play scene, and I go back, you may see that some of this goes away with my tsconfig.json file. My tsconfig.json file tells me how everything should be, right? This kind of configures everything, right? Strict bind call, no implicit this, always strict. Like there's a lot of these things that I can take away to show you this. So if I was to comment this block out just for a second, this is in my configuration, right? Yep.
Instead of remove from the constructor, remove from the start method.
Yes, I could. Yes, I could. So now you can see that it's okay, right? It's okay because one of these checks that I used is making me check for this problem, right? Make me check for this problem. So it says, hey, possibly might not be defined. It's a helper. That's all it is. It's trying to help you saying, hey, make sure you instantiate this thing, right? So I can start putting these things back. Let's just putting them one at a time to see which one it is. So is it no implicit any true? Is it this one? Let's see. And let's go back to my play. Right? No, that's not it.
You have to remove the comma.
Okay. And add one here. And let's just make sure that just because we're going to play around back and forth, let's use the play kind of on the side here. So I'll kind of do one of these. And I'll save this one and we'll go back to this one. So let's take a look at this and let's take a look at this. So here you can see that this is okay and I'm not getting an error up here, right? And I'm not getting an error down here where I'm getting it. So let's add them in. So here, let's add the next one. So I said no strict null checks, okay? So again, we have to remove the comma. We have to put the comma back in here. No implicit any. I think that should still work. I'm not sure why it's giving me that weird error. So that's one. And then let's keep going. So that didn't do any. Oh, there it is. No implicit any. Or strict null checks. That's what it's doing. Strict null checks. Because we don't know it's null. And then it doesn't like that. So if I put all these back. So I put them all back. And make this true again. But strict null checks, I make false. Then maybe it goes away. So I can just remove this. Because this makes sense for us anyway. but these are okay. The more you put here, strict, 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 strict. Remember, it's like security, right? The more security you put in, it's more safe. The more security you put in, less usable. Right? Truly, right? If it's really, imagine if you're trying to open a door, and whenever you get to a door, you have to do your retina scan, thumbprint, your heart rate. You have to, pee in a cup. You have to do a bunch of different things to know that it's. I'm saying they can make a lot of things to know that it's you. Imagine if you do that a lot of times. I mean, it can be pretty crazy, right? And yes, it'll make sure that it's you, but it might take you 10 minutes to get through that door. Imagine if you have to do that for every single door that you went through in your house. You have to keep checking that it's you. Is it you? Is it you? Is it you? Super secure. I mean, if the door holds out and if the walls are super strong, right? But really annoying, right? So there's got to be a balance between access and usability, right? We have to have that balance. And I think taking that one check out, I think will make this more usable for us. Yeah.
Why do you need to initialize the object again inside the start method?
You don't. That's what I'm saying. You don't have to do this at all. So what I'm doing is, now that I've updated this is where that came from. This is where the thing came from. So we're only going to do it once. We're only going to do it in the start method, not here. See?
Why not the opposite?
Why not?
The opposite.
Why not here?
Initialize everything inside the constructor and do not initialize it inside the start method.
It's up to you. I want to use my start method for initialization, and I want to keep my constructor clean, right? So that way you can see that the constructor is going to call the start method, and that's all you see in the constructor. Very simple, right? And then I do all my initialization somewhere else. So I can look in one place for all my initialization stuff, right? That's the reason why I'm doing it. Not because you have to. It's just my convention.
I thought it was a constraint.
No, absolutely not. No, you can do it any way you like. If you don't like that, if you want to do everything in the constructor, go ahead. I personally feel like I like doing it separated, right?
Great.
Yeah. Okay, so so this is this, and you can see my tsconfig.json has a bit of a problem, and it says that ensure non-undefined class properties are initialized in the constructor requires TypeScript thing. It says cannot be specified without using strict null checks. So I got to remove this too. So I can't do one and not the other one. I have to do both. It's like you have to initialize both things, right? So it's fine. I'm okay with that. Like, I'm totally fine with that. I don't know why I'm getting that weird error. I think that's a VS Code thing. There shouldn't be an error anymore in here.
Save it.
Yeah, I did. Save. Yeah, see? It's okay. All right, so so that took care of that issue. That means that we can go and update the other ones. So I can go into our start. So start, we've been doing this initialization. We can get rid of this initialization. Now we're starting to refactor a little bit. Start, we can go to play we did. We can go to end. Right, all this initialization stuff that we did before, right, we can get rid of this stuff. And we don't have to do this anymore because it's not necessary. It's slowing us down, in fact, right? So that's kind of cool. Game.ts, we're good. Let's look at other things too in our objects. Button.ts. Well, we're doing things in the button anyway, so we're okay here. I'm okay with that. And same thing with my GameObject. Is there anything in my GameObject that I cannot initialize? Like all this initialization here, look at this. All this initialization that I'm doing in my button. And I have a start method. I could do it here, but I'm doing it here because it's my GameObject. This is okay, right? However, by the way, there's another thing you could do. You can make a protected or private method called initialize, right? And then all the initialization happens. That's totally fine, right? So then again, you can restructure your GameObject.ts so that it does initialization, and then it does it in here. All these are all private things that I'm initializing. This is pretty good. Okay. Label, same thing. We're good. Ocean.ts, we're okay, right? Our ocean, we're fine. We don't have to initialize anything in the constructor, Plain, we don't have to do that. Player, same, and that's it. Okay, so we've done all of our work. Oh, maybe the vector. The vector. Do we have to initialize stuff in the constructor? Because that's again, it's like you said, it's like duplication. Why would I have to do it? If I can avoid doing it, like this initialization step, then I want to avoid it. Okay, but here it makes sense in the vector because there is no other place we do this. Okay. All right. So that's this. That's this stuff. Let's test to see if we add it to the scene. So again, I'm going back to my play scene. So going back to my play scene, my plane is what I want to update. So in my play scene, I have my plane. I instantiate my plane. So this is where initialization, initialize, and instantiate, right? That's what that happens. We're initializing and instantiating in my start. I update my ocean. Oh my God. Plane dot update. I update my plane, and now I want to update my. I want to add my plane to the screen, and it's going to be after my ocean. So this dot add child. This dot plane. Okay, so that does everything I need to make my play scene work. Okay, makes sense. Now let's see if it works. So play. Sorry, I have multiple scenes. This one's live, this one's not, right? So start, and oh man, I can move it everywhere I want. Yay! That's not what I want. I want my plane to be locked in the bottom, and I want to not be able to go outside my screen. I should not be able to do this. See? See this? That shouldn't be possible. I should be able to, and none of this. I shouldn't be able to go do it, because then I can cheat, right? I can go outside my, hey, I can move away from my stuff. That's no good. I don't want that, right? So I want to be able to lock my plane in place. So the way to do that is to go to objects.plane, this one, and what I want to do here is start thinking about my check bounds. So from a left boundary, when my plane approaches the left boundary, if the left edge of the plane is greater or less than 0, then I want to push it to the right or stop it. And the way I can do this is I can say something like this: if this dot position dot x is less than or equal to 0 plus half the width, which might as well just be half width. 0 plus half width is just half width, right? Then I want to say that this dot position, right, dot x, I can modify the x, or, which might be better for completeness, vector 2, I could say that it's going to be this dot half width, right? And then this dot position dot y, whatever the y is. Okay? That's what I could do. So that's the left boundary. So whatever my position is, I'm going to move to the left. I'm going to keep the same up and down, but I'm going to move my x is going to be locked to the edge of the screen. Similarly, for the right, then, if this dot x is greater than or equal to the boundary, and remember I did this, I said that, hey, I got on my config.game.screen width, right? We can check this now, whatever the screen width is, right? Minus this dot half width, right? Well, then what I want is for this part to be all this. Right? So then my x is going to be the this thing by half width, right? Also, notice that my move, I'm moving both the x with my mouse and the y. I'm okay to move x around, like left and right, but my mouse y should not be there. It should be locked at a certain amount, and I know the number, it's 430. How do I know this? I made this game just a couple times, right? And so every time I make this game, I know the number, right? So I put it in. Now, this is bad, right? Because I'm locking it in a certain amount. I could make it a percentage of the screen. There's things I could do to make this more, for other games if I want to make it. For now, this is okay. Cool. So I did all this. I moved my mouse. By the way, if you really want to be a stickler, see this number right here? I could make it so that there's a position that I put in my start. Like I could have a property. I could do that. No. It's just in the bottom. So what I mean is it's just going to lock it on the bottom part of my screen. So I don't move anywhere I want.
The mouse
Yeah.
When you move the mouse is positioned in the
Center.
0, 0.
No, it's in center. It's in center. Yeah. So, oh, it's not. Maybe it's not. Let's see if it's not. Maybe you're right. And if you want to make it center, then you would do this. We'd say 0, 0, and then true. That would do it. Yeah. Thank you for that. So yeah. So then what you would do is up here you could say something like the horizontal position. You could do that. You could say private underscore horizontal, or sorry, vertical position, vertical position, right? Which is a number. You could say that inside the start method, you could kind of set it up. This dot underscore vertical position, that's equal to 430, right? So locked to the bottom of the screen. And then what you can do is you can just put that in here, which is this dot underscore vertical position, right? Which makes a little bit better. Still not great, but better, right? And then, you could also use this 430 inside the configuration file, if, whatever. There's lots of stuff you can do here, right? Like, for example, if I was going to take my plane, right now my screen is going up and down, but what if I wanted to make my screen go this way? So then I could have vertical and horizontal position defaults. So when I go this way, then my plane goes over here, and it only goes up and down. And when I go this way, my plane goes down here, and it goes right and left, right? I can do that. So in other words, I can have like different kinds of levels where my plane goes up and down, or this way. It's up to you. But for now, this is okay, right? So then I'm checking, and then I don't need my reset, but I'll leave it here. Let's see what this looks like now. So here I am, and if I press Control, then you can see now it doesn't move. Even if I go up and down, it doesn't move anything. It stops me, and I can't get more than this, and I can't go more than this, no matter what I do, because it locks here, right? Which is what I want. So that's check bounce. So I can go right and left. You can see that it's also centered in the middle, which is pretty good. Are you with me? Getting there, right? So I got my plane and my island and my ocean. It looks pretty good, right? This is what it looks like. And if you look at my original one, which is, I don't even know where I put it now. Here, right? You can see that that's kind of the same, right? We're almost there with that kind of stuff. We have our scrolling ocean. We have we're missing islands and clouds. We have that. So what I want to do now is think about another control scheme, because right now what we're doing is we're adding in our plane, and our plane is moving because of mouse position. So mouse X and the vertical position. Wouldn't it be nice if I can press my buttons? Because a lot of times my buttons are the ones I use, not the mouse. And you know why the mouse? Why is it bad? Because I can do this, right? I go to my mouse and do this. That doesn't make any sense. My plane doesn't move like that in real life. I can't do this. I wish I could. Imagine that. Right? Like, that's a crazy plane, right? And so I could make it so that when I move my mouse, it follows my mouse slower. Right? I could make it so that I want to move my mouse where it is, but it's going to get there a little bit at a time. So I could make the mouse movement better. So how does this work? I could say that my position is equal to my mouse X, right? But not exactly my mouse X. Maybe I can make it so it's like 0.9, right, of my mouse X. So what does this do? So if I did this, then it does this, right? So look, it's kind of outside of my mouse, right? Not good. So that's like 90% of where my mouse is. I'm going to move this. But what I want to do instead is I want to say, okay, here's my position. I want to take my position and I want to interpolate between where my position is and where I was. So if my mouse position is here at, let's say, 200, and I was at 180, I want to get there, but I don't want to go there right away. I want to get there over time, every frame. And I've created a way of doing that for you guys. There is a, so in my, this object here, I have vectors, right? In my vector, I have different things, toStrings, normalize, 0, up, down, blah, blah, blah. But what I want to do is I want to lerp. That's what I'm thinking about, lerping. And lerp stands for linear interpolation. It's kind of a weird thing, right? So what is linear interpolation? Think of it this way. I have two positions, A and B. I want to go from A to B, but some portion of A to B, some portion, okay, some amount from A to B. For example, if I said from A to B, 0.1 of point A to B, I'm going to move 10% closer to B, right? If I want 0.2 from A to B, it's going to be 20% to B. Where 1, if I put 1, it's all the way to B. If I put 0, it's all the way in A. Right? That's what it's going to be. So from A to B. That's called linear interpolation. I'm going to interpolate somewhere in between A and B with some kind of t value. My t value is going to be my number, 0, 1, 0.1, 0.2, 0.3, all the way to 1, from 0 to 1. Okay? Does that make sense? Okay. So I need a formula for this, a little bit of mathematical formula for me to be able to do that. And if I look at the lerp formula online, let's get a hint of that. So lerp formula, right? You can find this online. So linear interpolation, right? Let's see if they give us the lerp formula. They actually might give us a thing. So lerp, Unity actually has lerping built in. But really what it's going to be is, this is not the great one. And I have another one. I have one, but I want to see if I can find one. If you were going to look it up, how would you find one online? This is all Unity stuff. So let's see linear interpolation on Wikipedia if they have. And they kind of do, but I'm not looking for the right thing. So one thing to always check is, this is the thing that I'm talking about. So here's B, here's A, and somewhere in between, you want to go between A and B. That's what you want to do, right? And that's what I kind of want to do. Every frame, I want to go from where I was to where my mouse is now. Every frame, every frame, every frame. Slowly, slowly going to get there, right? I could say, another way to do this without linear interpolation is, I could say that instead of me moving directly where I'm going to be, jumping to where I'm going to be, which is what's really happening here. I'm jumping to the new position, right? I could do what I did with my my ocean. I could say the position is equal to the new velocity, right? Velocity plus position. I could do that. And where my x is the new position, that's going to be velocity on the x-axis, right? Whatever that new thing is. And the velocity is going to be the difference in positions, where I was compared to where I'm going. I could do that, right? So that's going to be the velocity, right? And I can add that every frame. So I could do that too. But there's some great resources online. If there's some commercial game engines, one of them is called Unity. And if I want to, I can look at something called Unity decompiled, right? Unity decompiled gives us Unity's code, actually. And if I look at Unity's code, if I go engine, and if I look it down into Unity engine, I could see that under, they have all the math functions. And I like to include some of this stuff in our little game, because there's some stuff out there we can copy. So if I go back to mathf, and I'm gonna shamelessly copy this one, because I like this one. I'm being honest. So you can see that there's a bunch of little functions that come up here. For example, pi. A lot of times what they do is they define pi because we use pi so often. So this is not a bad idea, a bad thing to do, pi, right? And the same thing goes with negative infinity and degree to radian and radians to degrees and all this stuff. We don't want to calculate these things over and over again. We want to multiply by deg to rad to get radians. We want to multiply from rad to deg to get degrees. And so they have these little funky things here in order for us to get there. But there's one thing we can do is we can find a lerp function. So let me find that on the page. So lerp. And you can see what lerping is. It says I take two values, A and B, right? And then I return, I have a t value, which is like that number between 0 and 1. And I'm going to go from A plus B minus A, B minus A, times whatever that lerping value is from 0 to 1. Okay, let's try this out. So let's suppose A is 10 and B is 20. Let's look at this value for a second. So A is 10, B is 20. 20 minus 10 is 10. Okay, 10, multiplied by some t value. Let's say the t value is 0.1, 10%. What's 0.1 times 10? 1. So that means that a plus 1, which would be 11, is what it's going to return, which is exactly what it would be. The initial value plus 10% of the difference between the two values. If I had 20%, right, then it would be like this. It would be 2, because I would take 2 plus the initial 10, so it would be 12. So it would be 10, 11, 12, 13. We'd march along those things, right? So this is a great little function. But this little function doesn't belong in a config file. This little function doesn't belong in a vector necessarily. This little function belongs in its own math library. And we can make a math library. We're just going to call it util. Let's do that. So I'm going to make a brand new library here. So we have config, we have managers, we have objects, we have scenes. Let's make a new folder. New folder. And we'll call this folder util. Here's my util folder. In my util folder, I'm going to have my math. So I'm going to go in new file. We're going to call this math.ts. Okay? And in my math folder, I'm going to shamelessly copy this thing. So I'm going to say module util, right? Util. Oh. This is what happens at the end of the day. And then we're going to make a container class, right? Export class, right? It's going to be called math. Math. I don't know why it's doing that today. And then we're going to have some static methods. Static. The first method is going to be called, it's a function. So public static, not private, public static. And the function that's going to be named is called lerp, right? And it's going to take a few values, right? One of them is going to be called a, which is going to be a number. The second one is going to be called b, which is a number. And the third one is going to be called t, which is also a number, right? And then it's going to return a number. Okay? So public function lerp. It's not a function, it's now a method, because remember, classes don't have functions, they have methods, right? It's going to return a number, and we need to return this. We don't have clamp. I'm going to talk about clamp in a second. Let's add that in. So here is our little function. It's like math clamp 01 of t, and it's going to do this. What's clamp? We can put that in too, and we'll talk about clamp in a second, right? So clamp, let's find our clamps. Here it is, clamp 01. So clamp 01, what it does is it clamps a value between 0 and 1. So if you go beyond 1, it makes it 1. If it goes below 0, it's 0. That's what it does. Okay? So we can use this thing too. So we can say that public clamp 01. Let's make it C. Clamp 01 takes a value, right? So like it does here, it takes a floating value. So value, and it's a type of number. And it returns another number back. So returns a number. Okay? That's what it does. And I'm just going to copy this code. And what it's going to do, there's no double, right? It's just going to be a value. If the value is less than 0, then what I want to do, we're going to convert it to proper code. For us, we're going to return 0. 0. And if the value is greater than 1, we're going to return 1. So it won't allow us to go beyond those values. Okay? Return 1. Okay? Otherwise, return the value. So if the value is between 0 and 1, it just returns the same value back. That's what this clamp 01 does. Okay? Does it make sense? All right. So why is this giving us an error? It says cannot find clamp01. Do you know why?
What is that?
This is not static. Let's make it static. Right? Public static, right? Clamp01. But even then it doesn't find it because you need to use the explicit way of doing things, which is math.clamp01. We have to use that because this has nothing to do with this, right? Has nothing to do with each other, right? Even though they're in the same class, because they're both public static, they have no relation to each other, right? Yeah. So that's why you have to use the explicit way of doing things, math, okay? So now we have a lerp function. They have one more that they call lerp unclamped. So if I go lerp, sometimes what we also want to have is an unclamped lerp, which does from any number to any number times t, right? So this is kind of the same as this one, but it allows us to lerp without clamping. So we can say lerp unclamped, right? Which I kind of like that too. Sometimes we want to go beyond the number. We can overshoot. So if I go from A to B, but I give it like 1.1, just keeps going in the same direction, but past that, right? Which is kind of the, kind of a neat thing to do. So we can just kind of multiply by t here, right? So that's kind of the classic lerp. All right, so lerp unclamped, and clamp. For now, these are all the functions we're going to include. We can include other ones later, but this is a kind of a cool function to put in. Cool, I like it, right? However, I need to in order for me to use this new library, this util math library, I need to go into my index.html and put it in, and it's got to be pretty high up, like way up here somewhere, right? Like just like I have config, I don't need to know about any of these things. It doesn't depend on anything. So literally I probably could put it as the first library. So script source.scripts/util/math.js. So my own little math library. And we're going to add to this, especially when I do things like with physics and that kind of stuff. There are going to be other things that I can add in here, right? But I told you where I can get some of it. Like Unity is a good place. You can look online for some really cool functions as well. And you can include them so you can use them in your game. All right? So that's this. Okay, so now that I have this and I have my math library, I can use it inside of my plane. So I'm going to go to my objects, and I'm going to go to my plane. And now we can do something with that, right? So let's see what we can do. So we want to get this position, but I want to get the mouse x, wherever the mouse x is. Remember, this is a number, right? So my current position x plus my mouse position x with a t value, whatever that t value is going to be. So I can do that here. So I can just break this down into two lines. So I'm going to say that, so I'll say new position on the x-axis, right, is equal to my current position, so lerp, so util.math, right, .lerp, and I can pass in, right, a number a, which is where I'm from, so the.position.x, to where I want to go, this.stage.mousex, right, and some kind of t value, which is going to be something like, I don't know, let's try 0.1, right, for me. So that is the new position on the x-axis, and it says, can I find new position x? We're going to make it. We know this is now a number, right, number, and I can take this new position x and I can incorporate it right in here. So new position x. Okay, let's see what that does for us. Let's see if that makes any sense. All right, so going back to this. So you can see now that it kind of drifts. It doesn't allow me to do that crazy thing. And maybe, I don't know what you guys think of that. That's not bad, right? So it kind of gives me the drift, but I can move there a little bit slower, which makes my game a little bit nicer, right? By that linear interpolation. And if I don't like 0.1, let's try the other way. Let's see if it was 0.9. What happens now, right? That's a much faster movement, right? So let's try this out again. So you can see that's almost the same, right? So 0.1, well, let's go even lower than 0.1. Let's go like 0.01, like 99.9% of my movement. So again, if I go back, you can see that it moves way slower here to there, right? So it'll take a little bit of time for it to get there, right? Between one way or the other. So you can control this number, this t value, to whatever you want, right? It's a kind of a trick more than anything else, right? So instead of 0.1, we can make it 0.08. You know, let's try something else, something a little bit better, so that you can see if there's more smooth motion, right? Where you can, it's going to get there, depending where my mouse is. If I move it farther away, it's going to move there, right? So I could do this as a trick. I could do this, right? But I can't do this as much anymore. It's not as bad, right? Maybe that's not good enough. Maybe let's put it 5, right? So really prevent that motion, right? So again, you can see that it's not as bad anymore. You can move this as much as you want, but it's not going to move as bad, right? And it's going to take me some time. I want to kind of, it gives me a new strategy on how to move, right? Like maybe I have to move this way over here or over there, right? The other thing that we're not doing is we're not limiting the speed. Right now, it could be any speed I want, right? So we're moving between whatever the speed is, my new position x, I can compare it to my my current position minus my new position, and to get a value, whatever the value is. And I can limit myself to say the maximum I want to move is 5. Right? If I did that, then it doesn't matter how much I do this. It'll limit myself to max. And so now we can go back and get another function from the internet. Right? So here we go. We can go max and min. So we can go find max. Right? And I think max is kind of a really cool function to kind of include. The smooth step, gamma. I don't want to use gamma. Here we go. Max. So actually max is something that they use. They use approximately. I don't want to use this. Where's my mathx? So maybe there's a max function. There is mathf max. And that's when I go back to the place where they use it the first time. Really what it is a max and min. And I think it's included in our max function. Right? So I believe you can say that it's maximum between whatever this number is and whatever the number. So let's say, I think there's actually a math function. Math, like, you know, not math, but math from a JavaScript math. Right? Max. And we can say max from this number and another number. Like, let's say, for example, I'm just going to put it up there, 5. So it's going to return between 0 and 5. Right? So now if we try this out and go back, you can see what it does, right? So maximum 5. Okay, not great. Let's go maximum 2. Make it really extreme. So 2. 2. Right? So now it's maximum. The maximum we can move ever is 2 per frame, right? Depending on what I want. So this is going to create a new position x. But between whatever the lerping value is and 2, it's not quite what I want. It's not doing what I want. What I want is the difference between where I'm going to move to and where I was. So I want to say that let delta x, the change in x, right, be the difference between my new position and my current position. The absolute value of the difference between my new position, right, and my current position. Okay? And I want to use math dot absolute value. Math dot. Because math, the regular math function does that. And why is it giving me this thing? Expected, oh yeah. So delta x is the change in these two positions. Actually, let me just do that again. I meant the absolute value of the new position minus this position, right? That's delta x, right? So whatever that difference is. So if I say that, you know, difference between wherever I am and wherever I'm going, if it's 10, right? I want to take that delta x and I want to change that delta x so it can't be more than 5. So I could say that, okay, cool, then math.max between whatever the difference is and 5 pixels, and then we replace that with delta x. So between 5, whatever that is, the change, and 5. So let's try that. And you can see that I'm not moving at all. Because what is that delta x number? I don't even know. Whatever new position is minus this position. Yeah, that's not going to work. But you see where I'm going, right? I'm trying to calculate the difference between one position and the other position, whatever that is. So here it is. Here's the new position. My position minus the new position, and then 5. What's that number, right? And I want to say that that is the maximum number. I'm going to take the maximum is going to be 5. Actually, I'm sorry. I want the minimum, right? So this is kind of what I want to do. Let's see if we can do it in one. Let's see if I did it here. If I said that I want to take the minimum, math.min between this and 5. There we go. Let's see what that gives us. Not the max, the min. Okay. And you can see that that is like really slow, right? So I'm lerping between position and my stage, and that's really slow. Like it won't give me any kind of value at all, right? Same thing that we did here, except that we did it up here, right? So the minimum between whatever this is, the x and this, right? Because remember, the position starts off as new position starts off at 0, right? And then I say, okay, lerp between whatever this the current position is. Let's say, for example, 0, and whatever my mouse position is, which is, I don't know, 5, right? So between 0 and 5. Okay, do it in little increments. Cool. Now take the minimum between this and this, which was minimum, this one. And it's going to keep doing this minimum value every single time. So not a good thing. Okay. What other ways could we do it? Anyone else have an idea?
There is some method like sleep weight. You put a sleep weight. You know,
Yeah, I guess you could. I don't recommend sleeping. The other way to do it is multiply my new position is going to be this new thing, right? And we can feed it into like a min-max value. I want to be able to go from like a range. I want to go between this and this, right? So I can clamp it between two numbers, clamp, right? So instead of clamp like we had before, there's also not clamp 0, 1, there's also clamp, right? So clamp has two values, min and max, and clamps between those two numbers. That's not a bad idea either. So it clamps between 1 and 5, right? Minimum 1, maximum 5, right? As an example. So that's not bad. That's maybe the better way of doing it. So let's do that. Let's make a new function, and then we'll stop for today, right? But I'm just talking about bettering movement, making the movement better, more smooth, you know, as opposed to the way we've been doing it so far. Because right now everything is 100%, right, for moving. So let's make a new function called clamp. Again, it's public static. It's called clamp, not clamp 0, 1. And we're going to pass in those two values, the value, float, min, and max. But there is no float in JavaScript, right? It's just numbers. So we can do that. We can say value, which is a number, float, min, which is just min, and the number, and max, which is a number. I'm just translating what we have from C#, which is what that is, to JavaScript. Okay? And now we're going to do some changes here, just like we did before. So kind of similar to this, we're going to say that if the value is less than the min, then the value is equal to the min. Okay? Else if the value is greater than the max, then the value is equal to the max. And then otherwise return this. Let's make this so that it is done right. Looks pretty good. Good? So this is clamp. Okay, let's see how this works. Now this is great. Once we've added our class, we can continue to add to it. I can add more things to this clamp 0, 1. So this is clamp between 0 and 1. This is clamp between two any numbers, right? All right, so let's see if that helps us out with our motion. All right, so here's my plane. And I like that idea. I want to take whatever this number is and clamp it between this number, whatever this is, and 5, right? So 0 and 5. So I want to do this. I want to say that new position. I could let's make it so it's a new thing, just to make it so it's easier to read. I want to util.clamp util.math.clamp between and again here's the value, right, which is new position, and I want to clamp it between 1 and 5. So it can't go lower than 1 and it can't go faster than 5. Okay, and then I want to take delta x and use that instead. Okay, let's see what that does. Does that do what we want it to do, or is it going to make us impossibly slow again? What does it do for us? And you can see that that again is a problem, and the reason for that is because it can't do its lerping if I limit it. However, if I was to take, instead of new position.x, let's just comment this out, and if I said let's put in this position.x instead, because that does, lerping can't work with this kind of such scenario. So if I said, okay, I want to take whatever the position is, but I want to go between 1 and 5 pixels, right? Whatever that is. But that's going to be the x coordinate. That's what I'm clamping. The x coordinate. So if I did this again, it's going to be between 1 and 5. If I put 1 and 50, that means it's going to be between 1 and 50 pixels on the position, right? So I can only move from 1 to 50. If I put 1 and 500, then anywhere between 1 and 500 is where this is going to be. My mouse position.x, right? And by the way, stage.mouse.x is what I want. This one. I want to show you what I'm talking about here. So if I did this, then anywhere between up to 500. Beyond 500 won't work, right? So if I did 1 and 5, then it doesn't matter what I do, I can't go beyond 5. That's what clamping does, this mouse.x, right? So this isn't any good. This clamps the mouse, but I have to still calculate what my new value is going to be. What is my new value, right? So again, I got to move wherever my new value is minus my old value. I got to have a vector somehow, a velocity, right? And I got to clamp it between these two numbers. So again, I wanted to propose these things. Anyone else have any other suggestions? Clamping is a good idea, right? But it's a matter of finding what that delta x is. What is where I'm going and what is where I was, right? So again, an example would be, you know, I want to move my difference. My delta x should be the difference between where I was and what my new position is. So again, it would be something like the absolute value math.abs of where I was minus where I'm going. Okay? and I want to clamp it between 1 and 5, right? That's my delta x. And I want to add delta x to whatever my current position is somehow. Because that's just going to limit me between 1 and 5. I want to change the delta between 1 and 5. And it has to be, it can't be absolute value, because if I'm moving to the left, then it has to be left. If I'm moving to the right, then it has to be right. I have to, you know, add this to the mouse position somehow. Do you understand? And there's more work to be done here for me to do that. I have to find out if I'm going left or right. So if I'm moving negative, if my current position is greater than my new position, then I'm moving to the left. So I can do a kind of a if statement. I can say if new position dot x, right, as an example. Well, if that's greater than this dot position dot x, right, then I know I'm moving to the right, right? So moving right. And then the other one is the other one. If my new position dot x is less than. The noise is unbelievable. Huh? Then I'm moving left, right? And what about if it's equal? Then I'm not moving at all, right? Which is okay. So either one or the other. So if this is happening, then what I want to do is I want to add to the position, and because my new position dot x is greater than, that means it's my mouse is actually to the right of where I was. And if I'm to the left of where I was, I want to subtract from the position, right? So then my delta x would be a negative delta x, right? If that makes sense. So it'd be like something like, if I'm going to the right, then I'm going to say something like this dot position dot x. I want to say that it's plus equal to, and I don't want to do this right here, but something like plus equal to delta x. That's what I want to do. That's kind of what I want to do, delta x. I want to add delta x when I'm moving to the right, you know, and I want to subtract delta x. I don't want to do this exactly, but I want to subtract delta x when I'm moving to the left. So if my mouse position is to the left, then I want to subtract it, right? And I want to create a number between 1 and 5, whatever that number is. So this is where I can use the math.abs formula, right? I want to take the difference between whatever I am and where I'm going, and I want to make it clamp between 1 and 5, maximum, 5 maximum. And I want to take the current position, whatever this is, this current position, and I'm going to add delta x to it, right? Then I don't need this anymore, right? Because if I did this, then it's exactly what I want to kind of do, right? Let's see if that works. And see what it does. Oh, boy. Yeah, because I didn't, I'm not calculating the y at all. So, x, new position. And I'm adding to it, which is something that I'm going to be adding every frame. It's on the x-axis, and that's not good. What about the y-axis? Maybe what I want to do is count some of this. So I'm going to say that maybe it's the other way around. Delta x then, whatever it is equal to delta x plus the position. So it's the other way around. Delta x plus equals to this dot position dot x. No.
So maybe you just need to fix before the y-x. You just need to fix.
Yeah, no, I'm going to do that here with this vertical position.
Later, maybe you do when you create the object, you fix the y. Then because they move, you only are changing x. If
we
you
can
fix y before,
we can do that.
about y.
We can do that here. We can say that this is just this position. We can just do this, right? So minimum 1, maximum 5. It's going to lerp, which means it's going to speed up and slow down, right? And if it's too slow, then you can change the values. You can say that I want to make this 10, right? Maybe 10 is going to be okay, right? So again, you can't move faster than 10. You can't move slower than 1. Whenever I change my position, I can't do this anymore, but I'm also going to be limiting myself, I'm clamping myself to the number. So even if I go all the way here, maximum I'm going to move is 10. If I want to move fast, kind of thing. Because this is a big difference, right? Big difference. And this is not so big. And you can also say something else too. Instead of doing it 1 to 10, you can go 5. Minimum is going to be 3. Maximum is going to be 5. You can do that too, right? Where you can do a different value, right? You can try different values out. So minimum 3, maximum 5, right? And you can see how that works for you. But see this?
No.
That bugs me. Look at that.
Oh, got it.
Because of this. So again, you can fool around with these numbers. Personally, what I like more than all that is going back to what we had before, which is this. I personally like this motion more. So I don't want this because I've tried it. I mean, we're trying to make it so it's more smoother or whatever. This is neat. And clamping is neat as well because it limits you. But I think that the best thing for me to have, the best is what I had before, which is putting this new position in here. This is good enough, I think, for me. But I wanted to bring this up because, what you're going to get is people that were trying to cheat. This for mouse movement, it's not bad. It's not terrible, and you're going to see how this is going to affect our game. Even if I kind of zoom out or zoom in, it's not going to be, 100% control. Okay? So again, we're just trying to talk control schemes now. And we've added a couple of functions that might be useful to us later. Okay? All right, guys. I'm going to leave you with this. Remember that your assignment 1 is due Sunday now, not tonight. Okay? So that's something that I've changed. If you look at the updated due date, it's Sunday at midnight, which gives you a little bit more time. Things we covered this day today is we covered preloading, right? We covered putting things live on GitHub pages, which you need for your assignment number 1. We covered movement, a little bit of movement with the mouse. And next week we're going to cover movement with keyboard, right? Which is a whole other thing if you want to do it properly, right? So any questions before we go? Okay, I'm going to put this up on GitHub, and then I'll put the video up later on for you guys to see. But otherwise, good luck. Study for your test. Remember, next week on Saturday is when your test is due. For the other people in the other group, their test is on Tuesday at 6:30. Okay? So, guys, thank you so much, and we'll see you next week.